Multiple inheritance. Introduction. Multiple inheritance means the inheritance is implemented from more than one parent class. In this chapter, we will discuss the following topics. Inheritance as categorization. Problems arising from multiple inheritance. Inner classes. Inheritance as categorization. To define the process of inheritance, it is a form of categorization. Example, a text window is a type of window, so class text window inherits from class window. Most of the objects can be categorized by variety of ways in the real world. Example, the author of the textbook can be categorized as Indian, male, professor, and parent. They are entirely different from each other as these are not proper subset of the other. So single-rooted inheritance hierarchy cannot be made out of them. Inheritance as combination. Real-world objects are the combination of features from different classification schemes. Each category gives some new insight into the whole. Author is Indian, and author is male, and author is a professor, and author is a parent. Note that we have not lost the EC relationship. It still applies in each case. An example, incomparable complex numbers. If you have class complex which represents the complex number abstraction, it is advisable to make the complex class into a subclass of number. Complex numbers have the following. The two abstract classifications are magnitude, things that can be compared with each other. Number, things that can perform arithmetic. The three specific classification with the constraints are integer, comparable and arithmetic. Character, comparable but not arithmetic. Complex, arithmetic but not comparable. The difficulty is that comparison between two complex numbers is ambiguous, that is, complex numbers are immeasurable. Possible solutions. Create the subclass number for magnitude class, but comparison operators in class complex to give error message must be redefined if used, that is, subclassing for limitation. Avoid using inheritance. Redefine all operators in all classes. Use part inheritance but simulate others. Use number but have each number implement all relational operators. Number and magnitude must be independent and it can have integer inherited from both the classes, that is multiple inheritance. Another example, menus. A menu is the set of options presented to the user. A menu maintains a collection of menu items. Each menu item knows how to respond when selected. A cascading menu is both a menu item and a menu. Problems arising from multiple inheritance. Problem with multiple inheritance. Name ambiguity. The most common difficulty arising from the use of multiple inheritance is that names can be used to mean more than one operation. Car extends vehicle, truck extends vehicle, and assume driver can extend both car and truck. What would be the problem? Consider both car, truck has the same method drive vehicle. Now if a driver class wants to drive, it gets confused whether to drive vehicle of car or truck. One solution, redefinition. One solution is that to redefine one or the other operation in the child class. The below given example shows multiple inheritance concept. In here the class driver extends to class car and truck. The drive vehicle method is defined as virtual. Problem with redefinition solution. However, the redefinition solution is not without cost. Now what happens when we run up against the principle of substitution? Driver star drive equal to need driver of. Drive vehicle. This statement draw vehicle of car or truck. Here compiler gets confused. This problem can be mitigated but the solution is complex and it is not perfect. Other approaches to name ambiguity. The other programming languages use different approaches to solve the problem of ambiguous names. EFL use the ability to rename features from the parent class. A polymorphic variable accessing through the parent's name will access the rename feature in the child. CLOS and Python resolve ambiguous names by the order in which the parent classes are listed. The first occurrence of the name found in a systematic search is the one selected. Multiple inheritance of interfaces. Multiple inheritance of interfaces does not present the same problem of name ambiguity as in multiple inheritance of classes. Either the ambiguous methods in the parent classes have different type signatures, in which case there is no problem, or the ambiguous methods in the parent classes have the same signature. Still there is no problem, since what is inherited is only a specification, not an implementation. This is why Java permits multiple inheritance of interfaces, not of classes. Nevertheless, C# does not permit the same method name to be inherited from two parent interfaces. Inheritance from common ancestors. Another problem with multiple inheritance occurs when parent classes have a common root ancestor. Does the new object have one or two instances of the ancestor? Data field in common ancestor. Let us assume that the common ancestor declares a data member. Should the child class have one copy of this data field or two? Both answers can be justified with examples.
C++ has implemented this concept using the virtual parent class. If a parent is virtual, there is one copy, and if not, there are two.
Inner classes. The ability to
Extend
classes in C++ and Java provides a mechanism that is nearly equivalent to multiple inheritance without the semantic problems. The below example shows the inner class inner child, which is declared inside another class child. These two classes extends the parent class named as parent1. You can access methods from both parent classes within the inner class. This idiom is used a lot in Java. It solves many problems that would otherwise be addressed using multiple inheritance. It is not exactly equivalent to multiple inheritance, but very close. Summary. Chapter Summary. Inheritance as categorization. Problems arising from multiple inheritance and inner classes.